So I think it was in English in the schedule, so unless everybody here says that they prefer Spanish, I think I am going to switch to English. Let's begin. We are going to talk about platform engineering. I am Horacio González. As you can maybe hear, I am a Spaniard who has been living in France for over 20 years. So my English accent combines the worst traits of both Spanish and French accents. Sorry about that, people. I am head of DevRel, Developer Relations at Clever Cloud. Clever Cloud is a cloud provider, a French cloud provider, and the main difference with the generic cloud provider is that we are doing a platform as a service. We are doing a cloud by developers for developers. We will talk about that later. I am also organizer of several conferences and communities in the west coast of France. And we are here to talk about platform engineering. Or maybe better, we are here to talk about complexity. We are going to travel in the time to go back 30 years in the IT, and we are going to see that we have been adding layer over layer over layer of complexity, and the developer job has become something completely different. I began coding in 1994. I began with Pascal. I had done a lot of BASIC before, but my real beginning of code was Pascal. And then I began to do Java. And at the time, when I wanted to develop a new application, it was rather simple. Simple, not easy. I had my code editor. I wrote my Java classes. I added my dependencies, my jar, and I launched Java-C, the compiler, and I got some .class files. Then Java and the class name, and my app was running. Last what, like I learned to code Java. Several years ago, I began to teach Java to students. And to students that were switching their life path. They had another career before and they wanted to become developers. And I realized that for them to code Java was only the beginning of the problem, because before being able to be considered a Java developer in enterprise, they needed to learn all of other things that didn't exist at that time. And most of them weren't development. I mean, if I was a student now, I will be really, really, really scared. For every problem, there are 220 solutions, and it is your responsibility to choose the right one. There are a lot of ways to deploy the same application, and yeah, it's like that. You see, it is wonderful. You have really one tool or several tools for every need. Well, for me, that's a problem. Platform engineering tried to offer one way to solve this problem. One way to reduce complexity, but to empower developers too, because historically, the way to reduce complexity was simple. There was some architecture or methodology team in the company that say, you use that, and that. So complexity was reduced, but also all the freedom of the developer. It was replaced with process. Now, we are going to talk about platform engineering, and it is an approach that it is still beginning, and we hope it can maybe hold the promise and reduce the complexity while empowering developers. But before that, let me go back in time. I see in the room, I don't feel alone, because in other conferences, most developers are in between 20 and 30 years, and I am like the old grandpa telling silly stories. But here, there are a lot of people like me. Hey, you are my people, thanks. You are going to remember these things. Let's go back in time. We are in the 90s, in a time almost forgot, when internet was young, where Windows 95 was cutting edge. Hey, how many times you have spent looking at this screen? When big companies still use mainframe, no, that's true yet, but even more than now, let's say. And in that time, deploying things was easy. Easy if you had a server. It was the reign of bare metal servers. Companies usually had a server room. For most companies, the server room was a small room behind the coffee room, you know, where there was a single rack and 3 or 4 servers. And when you arrived to the top of capacity, you added another server, but it worked. It was very different than now. And also, the way as we organize work was different. There wasn't any experience of the best way to organize IT. So most companies used it the way they knew, the industrial model. Hey, it's not maybe the model the most adapted to the IT, but it was the only one. And of course, we created silos and hierarchies and responsibility, and we separated the project owners from the developers, from the sysadmins, from the ops, from everybody else. Hey, it was the traditional way to do things. So we were treating development like we treating factories. After all, developers produce things. They work as in a factory. Let's try the same thing. A spoiler, our cat developer wasn't happy, but it was the only way. And another thing, and it will be our leitmotif, and most of things we're still doing in a kit-bashed way with plain old bash or things like that. By the end of the 90s, things begin to evolve. Things begin to evolve because technology allows it to evolve. So the first evolution comes with the tooling. Do you remember when you code an application by the end of the 90s? You had your application in your editor. This one was from the beginning of 2001, 02, our old Eclipse. And you went to the website of your libraries to get the last version of every one of your dependencies. Hey, I have seen there is new Apache Commons IO, let's get it. Hey, but it said it needs another library in version 3.0. I am going to the site of the other library to get its dependency, and all that. For me, the first big evolution was when the tooling began to change that way of things. First change, source control. Do you remember how you did version control before CVS, clear case, or things like that? Copy in a new folder and rename the folder with the date. Yeah. Source control, even if at the beginning it wasn't really user-friendly, who here has used clear case? Anybody? Nobody? CVS? Yeah. Do you remember when you tried to do a merge with CVS? I still do that. I still remember. Another big change, when you were able to begin to manage dependencies using Apache IV with Ant or Maven. Hey, you don't need to go to 30 different websites to get the 30 different libraries in the last version. You updated your configuration file, your XML for Ivy or for Maven, and your dependencies were updated in a magic way without conflict. Do you remember that? What about testing? We began to get things like Hudson before it was renamed as Jenkins, or Unit. That changed the way as we code. People began to think, hey, we could also do unit test, or even doing the unit test before the code, or the monitoring. Nagios, Cacti, Savix. Before that, monitoring an app was spending the night in face of a screen with a green or red light, and if the light was red, there was a problem in the application, you connect to the server and you try to understand what was happening. And now you have metrics, you have graphics, you have traces. So the tool evolved. So many possibilities. But in a few years, we made our developers, like our cat developer, to manage this complexity. Suddenly, your job wasn't only to code, but also to manage all that. Well, but it's for a good thing. Yeah, fully agree. And of course, we still use Bash. But let's go to the beginning of this century. Do you remember extreme programming? It seemed wonderful on paper. Simplicity, communication, feedback, respect, and courage. Who could read that and not feel, wow? And even better, 2 years after, the Agile Manifesto. Individuals and iterations over process and tools. Can you imagine that? We were going to get free from all those process and tools. We were going to break the wall, to break down silos. It was wonderful. Well, it was wonderful until somebody decided to codify agility. Individuals and process and iterations over process and tools. Let's do a daily scrum where everybody must spend 10 minutes telling what they did the precedent day and what they are going to say today. Let's do a sprint planning where you decide how many, not time, because time is not good in Agile, how many effort points are you going to put in every issue for the next 3 weeks. Really, individuals and iterations over process and tools. Everybody loves Jira. So yeah, on paper, it was wonderful. And I know that you are laughing because you have lived this period. You understand my pain. In fact, we were back to the old industrial model we tried to do. We codified everything. It was codified agility. But don't worry. 10 years after, in 2012, we had DevOps. DevOps was going to solve the big problem of the wall between developers and operations, making everybody work together. The key word was together. Devs working with ops. Ops working with devs. Do you agree, I think? Well, most companies didn't. They decided that DevOps was a nice keyword, but they wanted to implement it in a way that fitted with the culture. So they had lots of anti-patterns. Devs who are part DevOps, but there is another separated ops team. DevOps and some DevOps team, or Dev and Ops fully separated. You have a lot of other DevOps topologies, or I should say anti-topologies, in this wonderful site. And you are going to read that, remember your experience, and you are going to cry like I did. Yeah, wonderful. But I especially cry when I try to look at the job offers. What the fuck? Yeah, I'm in Spain, I can say fuck. What the fuck is a DevOps engineer? What the fuck is a DevSecOps engineer? A DevML ops? A DevAI data SecOps? All that, I have seen that in LinkedIn. That's the definition of a company of what is a DevOps engineer. They need to know everything. It is not a job, it is 5. asterisk ops, dev everything ops. For the companies, it's wonderful. They pay one person and they have 5 jobs. Nice. But for the poor developer who now has to know everything, well, we have to deal with the cult of agility that says that the real agility is not to move and do your daily scrum or your sprint review, sprint planning and all that, and you have to know 5 jobs in order to do only your job. Nice. Our sad developer cat is even sadder. And, of course, if you look at under the hood, it was still mostly bash. But now, 3 years after, things are going to change. This time, it is sure. We have the cloud. Cloud is wonderful. You are going to use the infrastructure at its maximum capability. You are going to be able to deploy in the clouds, en las nubes. Wonderful. Well, for companies, it has a good effect at the beginning, at last. You needed to learn to automate things. If you have a cloud provider, what you are doing is allowing your users to create, compute, and storage and network on a click without a human intervention. But at the bottom, you have real data centers with real servers, with real switches, with real disk. So the only way to do that was to automate. And for developers, it was a big change too. Before, when you wanted a new server, you had to do a purchase order and wait 2 days, 3 days, 2 weeks, and then you got your server. Now, you do click, 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 and your server is there. It is wonderful, no? Yes, because it empowers developer. Or at least, it was the argument everybody used. Now, as developer, you can, on your own, choose and deploy your infrastructure. Hey, deploying infrastructure is maybe not a developer job. No, you are a super developer now. You can deploy your infrastructure. Okay. And you have to learn new things because by default, in the cloud, everything is cloud native. What's cloud native? Everything is distributed. When I was young and I had hair, at the university, one teacher told me distributed computing is one of the most difficult problems in IT science. Don't do it unless you have to do it. Well, now, 25 years after, every problem is a distributed computing problem because distributed is the new by default. And who did all this automation? Developers. No, sysadmin that learned to code in I don't know where. Because now sysadmin, they have to code. Nobody has asked sysadmin if they want to code. Most of them, when they choose sysadmin over development, it was because they didn't like to develop. They like to play with servers, infrastructure, big toys, not to develop. Now they need to develop. And not only that, we have new roles that appear. Do you remember the dev asterisk ops? Now we have things like SRE, System Reliability Engineer, something like that. Well, in fact, what's that? Sysadmin who code. Okay, fancy name for sysadmin who code. So our poor developer cat now needs to deal with this complexity, with the 250 products of every cloud provider. And now it has the responsibility to choose and deploy the infrastructure and to deal with that. And if you look under the hood, even on the cloud provider, there are many things that are still doing in the plain old way, but on the cloud. Okay, no problem. Too much complexity, I have another solution. We are going to add a new abstraction layer. So we are going to solve the complexity problem, but by adding a new layer of complexity. Like our friend, like containers. It was nice. Now you can have in your laptop the same things that is running on the cloud in production. Well, first thing, not true. That isn't a production WordPress. You have two containers and database in your laptop. In production, you have maybe the same containers, but in several instances with redundancy, with other things. But don't worry, containers are the future. Nice. And as containers are the future, we are going to take our old trusty app and we are going to split it in 20 different apps. Let's call that with a fancy name, microservices. In fact, it is nice for engineering managers. Before you have your application with 40 developers, and the 40 developers needed to coordinate by themselves in order to be able to put in production. Hey, wait a moment, I am working in this feature, and okay, I need to stop this one. Okay, everybody's okay, we can release. Now you have your 40 developers working in 20 different microservices. From a project manager or engineering manager point of view, it is wonderful. The two developers in the login microservice are going to be fully independent of the two developers in the back office microservice. It is nice. But for people who has to administer that, before you had one application to deploy, one application to maintain, one application to securize. Now you have 20. And the 20 are speaking one with the others every time. From the sysadmin point of view, the microservice architecture created a lot of complexity. So we need yet another solution. What can we do to solve a complexity problem? Well, you know my answer, no. In IT science, you have a complexity problem, you solve it by adding another layer of complexity. So let's make sysadmin lives easier. We are going to create an orchestrator. If you don't know Kubernetes, the easiest way to understand this is like an intern. You know the intern you get from third or fourth year of informatics or telecom engineering. Hey, welcome to the company. Here you have our instances, and here you have the instruction. I want you to deploy these 20 microservices. The front end, I want you to deploy it in 2 instances, and the backend in 3. Where? I don't know, you have the infrastructure, whatever you want. And I also want you to add a database, MySQL with high speed disk. Where? Hey, it is your job, you are the intern. And please, you also securize that. And you add some airbag framework for the access, and you monitor that. If there is any problem, you repair it. I will be at the coffee room. Bye, and welcome to the company. That's Kubernetes. Well, that's the publicity they do us of Kubernetes. Because in order to explain all that to our intern, we need to learn how Kubernetes works, what are the Kubernetes objects, how do you declare all that, and you must write some hundreds or thousands of lines of YAML. Who here loves YAML? Hey, you have courage. You are my hero. You are the first person when I have given this talk who has dared to say he loves YAML. Really? Who can... I believe you, but I cannot love a language where every space is important and you need to write 1,000 lines file of configuration. But yeah, it solves a problem. It makes sysadmin life easier by adding yet a new layer of complexity. Well, But if you have a lot of Kubernetes and things outside Kubernetes as 3 cloud providers, we still have too much complexity. Okay, let's solve that. Let us another layer of complexity, infrastructure as code. So now you are going to be able to describe with code in which cloud provider you are deploying which services. Nice. So now our developer needs to be aware of containers, Kubernetes, pod services, deployments, Ansible, Terraform. No, Ansible and Terraform, this slide is old. Now they are both from the same company, so we can mix them. Maybe Terraform, Ansible, Terrible, which is a good name for the new tool. But you understand. And of course, there is still a lot of YAML. So we are here in 2024. There are people who want to become developers, and they need to learn all that before being able to be an enterprise developer. It's a problem of complexity. There are too many options. I have done things fast. I don't have the time, but I have been beginning to talk about the 30 different services for the same need, sometimes in the same cloud provider. Anybody here really understand any of the services catalog of one of the 3 main cloud providers? Really? And everybody tries to say, it is nice, you now have the power to choose. Everything is self-service. Well, the power to choose is really the power to have a big cognitive load. You, as developer, are responsible to choose the right tooling, the right service, to deploy things, to, when things aren't working, to try to see why. It is even wonderful if you get 1 hour a week to do code, no? Platform engineering tries to solve that, but, and that's my own comment, they try to do it not by adding complexity, but I am sure that if platform engineering becomes mainstream, in 2 or 3 years, I will be able to do the same talk adding platform engineering as a new complexity layer. The only way it could change if everybody here and elsewhere try to say, hey, maybe we can do it differently for once. So I am always optimist. I am like a Care Bear, always smiling, always trying everybody to be happy. I think it can be done, but to be realistic, I am fairly sure that in 3 years I will add platform engineering to my complexity layer thing. Let's try to dream. The definition was done by Luca Galante, one of the first person to try to theorize that. It is complicated, but the idea is, okay, we want 2 things. We want to reduce the complexity for developers, but we want them to be able to keep their freedom to use the tools they need. We don't want to say to the developer, when they say, hey, I need to do that, no, you can't. We want to say, okay, wonderful. Here you have a way easy to use, and if you need other things, let's work together in order to allow you to do it. And that's the idea of an internal developer platform. Hey, you are old like me. You have seen this idea hundreds of times. Well, most of them in proprietary way. Some company who said, we are going to create some developer portal, or we are going to, but usually it was a big mix of things, Git bashed together with some proprietary things that the people who coded it quit the company 3 years ago. No, we are talking here about trying to do it in the right way, creating and maintaining an internal developer platform based on open standards that make developers' life easier by empowering them, not cutting the options, but reducing the complexity. And in order to create that, we have 3 interesting pillars today that are mature enough. In the first time, we have the GitOps philosophy. We are going to talk about this. We have many ways to create this platform, and we know the things that work and the things that don't work. And interesting enough, it isn't enough to create some tooling. You need to also adapt the organization, adapt your team, because a platform who doesn't live, it isn't a platform, so you need also to put some people power behind. Let's go in the details. GitOps. The idea is simple. Well, if instead of adding every time a new tool, you try to leverage one of the tooling that every people in IT, developers, sysadmin, SRE, ops already know, Git. Git has become the standard de facto for source control for many good reasons, and the idea is you treat everything as code. You treat your deployment as code, you treat your infrastructure as code, you treat your workflows as code, and you try to have a single source of truth. The idea is really this single source of truth. Example, you have a problem in production. Your sysadmin goes to the server, sees there is a problem in one configuration file, she or he patches it live, and the problem has disappeared. That's the old way to do things. It doesn't work very well, because next week when you are going to redeploy your server, because in a cloud world you are redeploying your servers every time, nobody has thought about applying this patch to the new server. GitOps. Your sysadmin goes, see the problem, and instead of applying the patch, they put the patch on Git, and they apply it to all the servers and to all the future servers of your company. If you begin to do it, you can get a new way to collaborate between your different teams. Everybody is doing things, and things are written down in a way that everybody can understand. You have visibility and auditability, and you improve the security, and especially you are able to do things more reliable around a single piece of tool. For me, GitOps changed how many things are done, but it is not a magic wand. It is simply a first step. The second step, if you want to have an internal development platform, is to create your platform teams. I mean, this book, Team Topologies, it is done by a guy, a Portuguese person living in Madrid. It's really, really interesting. You have the website. I am not going to resume that in 5 minutes. The idea is, if you want to create a platform to allow your developers have the right tooling at the hands to be able to do their work without cutting their freedom, you need to create a living platform. Something that needs to evolve, because development world is evolving every time. Something that needs to be enhanced, because there are new needs and things that weren't in the platform 2 months ago. And in traditional way of doing things, you will say, you cannot do that. If you want your platform to be used, you need to say, okay, right now we are unable to do that, but you can use that, and we are trying to add that in a proper way to the platform. So you need to have a topology, a team topology that supports that. You have your product team, he calls them a stream-aligned team. You have your platform team who builds the platform, and you also have two other kind of teams, the complicated subsystem team, because there are problems that are specific, that most teams have, and that ask for a specific knowledge. And right now, in many companies, every new project tries to find the same solution to that problem. For example, authentication. Authentication is a problem that is for all the applications of the company. It is asked from a specific knowledge and skills. It is the best if you have a team that deals with that. So we have three kind of teams for the moment: the platform, the product teams, and the teams who deal with the specific problems. If you want it to work, you also need an enable team, an advocacy team, a facilitator team. You can call that as you want, but the idea is a team who makes people work together, discuss how they do things, discuss the solution you have, go back to the platform team to say, hey, the solution this team found, it is better than the current solution in the platform. We can try to add it. People who are there to put some oil in the machine to be sure that everything is working. So for the moment, we have an organization, we have a single source of truth. We can try to build this platform. First thing is to remember that your objective is to propose a golden path. You are enforcing people to do things in your way, but you are proposing a way that works, that it is easy to use, and that allows a good developer experience. You aren't there to say, you must use that. You are going to say, hey, look at that. It has 80% of what you need in a really easy way to use. And most people are going to take it and use it because they see the interest. You aren't there to force. You are there to help. And for that, you need to have a clear mission and role for this platform team. They don't need to be the old methodology team that gets recycled to and name change. You need to have a team whose the mission is to create and maintain this platform. And it must be shown as a product. I mean, you are all developers. You don't create an IT product that you do a bridge. For a bridge, you do your plan, you build your bridge, and then one day the president arrives, he cuts the ribbon, and cars are over the bridge, and your work is over, and you go to build the next bridge. In IT, you are creating products in an iterative way. For your internal developer platform, you need to have a product approach. You need to say, my platform won't never be down. It will be alive, because development world is changing all the time. You need to make your platform more capable every moment with the new trends, new tooling, new everything your developers need. Even if your company is really convinced by the platform engineering approach, you aren't going to have an infinite budget. So you need to focus in the common problems, the problems that most teams have, and the problems when you can get some quick wins, especially at the beginning. Hey, I want to create a platform engineering team for my company, but we are going to be only 3 people. How we begin? Well, go to see all the other teams, and what are the worst part of your job? Well, I must choose every time I begin a new project, I must choose the right storage solution. Okay, all that. Well, we need to decide how we get our database in our cloud provider. There are different plans, different products. We only need a SQL database for the project. Okay. When you begin to see that there are problems that are common to most of your company, you solve that problem. You get a quick win. You go back to the teams. Hey, you can continue with your pain point or you can try our approach. And then you begin to have people in the company who root for you, who believe in your project. If you continue to do that, you are going to create a platform. It won't be complete. It won't be full scope, but it will be enough to make people use it to get traction. And that's the best way to begin and to grow your platform. Another thing is you must remember, and your hierarchy must remember, that when you are building and maintaining a platform, what you are doing is to create glue. The glue that allows the company to continue to go faster, to be performant, but you aren't creating value directly. And that's a problem, because for most companies, if your team isn't creating value, isn't selling to the customers, you are a cost center. Your company, your hierarchy, your team need to remember that what you are doing is valuable. The glue has a value. I love this slide. Do you remember maybe the film, especially if you are old like me? There was an earthquake, the rail was broken, the train was coming. So, what Superman did? He was glued there. He didn't repair anything. His only work was to be there to be sure that the train could continue. But it was really valuable. If not, the train will be down the bridge. A platform is the same thing. You aren't creating value directly, but you are allowing your developers to be way more performant and reducing the cognitive load. And you are also avoiding a lot of problems, because if every developer has to create its own solution, there are a lot of these solutions that are going to be not optimal, that they are going to be bad, and a lot of others good. But if you give them a solution directly from scratch, you know that the solutions are going to work. So you are creating value but being glued there. And you are there to make your developers' life easier. You aren't going to try to create the perfect solution. You aren't going to try to create your solution. You are going to create good solutions for your developers. So you aren't there to reinvent the wheel. You are there to create and maintain a platform that solves their problem. Of course, Bash will still be used, but if you do it well, maybe the sad developer cat won't be sad anymore. As I told before, sometimes the only thing we have is the hope that this time we won't add a new layer of complexity. I have 5 minutes to give 2 quick examples. The first one was about Kubernetes, because I discussed the room. How you can begin to create an internal developer platform in Kubernetes? My experience, what I have seen and done. First thing, don't try to put everything in Kubernetes. There is no real need, and it is usually a bad idea. Your database, you can put it in outside providers. Your legacy APIs and application, don't try to shoehorn them in Kubernetes. But you can try to operate them from Kubernetes. And the keyword there is operators. Kubernetes operators are wonderful because they allow you to extend Kubernetes and make it understand new things. Spoiler, those things don't need to be in Kubernetes. You can create Kubernetes operators to manage external resources. So even if you aren't putting your databases or your legacy APIs in Kubernetes, you can control them from Kubernetes. You can make Kubernetes the center of your internal developer platform. There are a lot of operators who exist today, a lot of open source, but here we're in a Java-like conference. It is really easy to create a new operator, especially in Java with the operator SDK, but in most languages you have an equivalent SDK that allows you to create operators in an easy way if you don't have already one for them. But well, now we have a lot of operators. How can we avoid the complexity trap? We create an operator to operate operators. There are a lot of solutions. One I love is Kratix. Kratix is an open source framework for Kubernetes that allows you to install, configure your different operators and offer them as resources to your developers. Like that, your developers doesn't need to understand what operator you are using to deal with which database in which provider. No, you are going to give them some custom resources, and that's all they need to know. Platform engineering. I need a MySQL. Here you have a custom resource. Okay, in which provider? Don't worry, you have a MySQL. You are a developer. What you want is a MySQL, not a MySQL in this provider. And that's a good platform engineering approach. And of course, put that with a good GitOps with CI/CD, for example, Argo CD. So combining Argo CD with Kratix with the right operator, you are going to create a platform that for your developers that are already using Kubernetes, the only thing they need is to use your custom resources for the database, the external API, whatever they want to use. And it makes things easier, and you are dealing with the complexity to make your developers' life easier. But, and I am finishing with that, you don't always need or want Kubernetes, especially if your company isn't working with Kubernetes now. I told before, that was my favorite workflow. I really love that. Well, today you can do it in a slightly similar way. You write your code, you put in Git, and you choose a Git to prod solution. We called that platform as a service before, but it isn't simply platform as a service. It is allowing the developer to center themselves in their job, to develop, and putting the cloud at the level it should be. We take the code and we put it in production, and all the details, all the complexity is managed by the cloud provider. There are some of them. Heroku was the pioneer of that several years ago. There are others. Hey, it is the last minute. My favorite one is my company. But as I said, there are others. Let me explain by example. I choose what kind of application I want to deploy. I give it the Git address of the application, and I define what parameters of scalability I want. A small instance, a big instance, a small instance, but allowing it to grow to 3 big ones. And I code, and I push my code. The other work is the cloud provider part. We take the code, we build it in the same way that if it is Java, you are going to have your Maven file or your Gradle file. We use it to build, we deploy, and we keep it in operational condition. So for me, if today you aren't using Kubernetes, look at a Git to prod solution, ours or another, but have a look. Ours is better, of course, but have a look at any of them, because you don't really need in an obligatory way to go to Kubernetes today. Let's finish with some links. My favorite one is a link to the past, but you have some others there. And you have everything we have seen. I am going to put the slide on Twitter, of course. about DevOps engineering, DevOps topologies, platform engineering, team topologies, Kratix even, and of course, Clever Cloud. And that's all for now. Thank you very, very much. I don't know if we have time for one question or two. So as nobody says anything, I think we can try to sneak a small question. Some questions or comment, anything? Yes, please.
So this cloud engineering people who do that, who are they? Developers, test DevOps?
For me, they are DevOps in the real sense of the word DevOps. They are developers and ops. You need to have some teams that have the two skills. As I said, I don't really believe in the super developer who is a super ops. I will try, and when I try to do it, I try to build teams who has the both competencies. Some people more dev, some people more ops, and people who are able to understand how the others are working. The real meaning of DevOps, for me. Any other question before I close my computer? No one? Well, if you have other questions, I am at the Clever Cloud booth in the main room. So thank you again very, very much, and see you later.